Let n points be placed on the circumference of a circle. What's the probability that the convex n-gon formed by these points contains the center of the circle? So the question is, we have a circle here and we have n points on the circumference of the circle. Joining these points would form a polygon, and the question says, what's the probability that this polygon formed by joining these points contains the center of the circle? So let's see how we can approach this question. The key idea behind solving this is that the center is within the convex n-gon if and only if all points do not lie on any semicircle. So if all of the points which are on there on the circumference of the circle lie on any semicircle, the center would never be contained within the polygon. So that's the idea that we'll use to find the total number of arrangements and the favorable arrangements. Sorry, the favorable arrangements and the probability. So let's assume that the n points are chosen independently and uniformly on the circumference. So this is our circle and this is the diameter. Now let's say we fix a point on the left side of this diameter here and we call this pi. Now we have two semicircles here, this one and this one. Both of them have the same length. So all of the remaining n minus 1 points can be in either of those semicircles with equal probability. So the probability that each of the n minus 1 points falls in this semicircle, we are talking about this one on the top, would be 1/2. And since there are n minus 1 points, the probability would be 1/2 to the power n minus 1. So probability that each of the n minus 1 points falls within this semicircle starting from pi going 180 degrees in clockwise direction, this half would be 1/2 to the power n minus 1. Now, since there are n possible choices for the point which we had fixed, which is pi, we will have to multiply this probability to permute for all of the different variations. So the probability that all points will lie within this semicircle would be n times 1/2 to the power n minus 1, and therefore the probability that the convex hull contains the center would be 1 minus n times 1/2 to the power n minus 1. So this is the answer to this question.